Hello, you're here with data science teacher Brandon, and today we're going to be doing a simple version of Hugging Faces, really an introductory project for this transformer library. So just if you're not aware of this, Hugging Faces, the actual library that we're going to use is transformers. So Hugging Faces, like the website, the company, and the name of the library is Transformers, just to make things confusing if you're new to this. Really quite easy though, so Transformers is Hugging Faces for all intents and purposes. I'm using Google Colab, so it's not inherently installed on of all the libraries in the environment on Google Colab. It's installing Transformers and data sets as well. Okay, both from the Transformer, the Hugging Faces company. Okay, so we're going to import our standard data science libraries. Going to import here train test split from sklearn.model selection regex. Here we're going to go from transformers. Let's import DistilBertConfig. Next one here is DistilBertTokenizer. The last one's a little bit of a longer one. So TFDistil. And so I have the membership to the subscription to Google Colab, the new AI, the Colab AI. I don't know if you can see behind my picture, but I think it's nice to have this text generation, but it makes it difficult to practice. So what we're going to do today is it's okay to use it. And if you absolutely know what the code is, what the line is, okay, fine. You can use it to fill in the rest of your sentence. Sometimes it's really boring things that you need it to do. And it's good to help you check your spelling as well. But our fingers are going to help us remember so much. So by not using it all the time, only when necessary to help us come with ideas, we're going to get more value out of it because we're really going to be learning this, and then we're really going to be able to do this on our own project next, or when we don't have this AI assistant, we'll still be able to do coding. So really important to really try, and for this guided project, we're going to make sure that we type out everything, even if we have that AI helping us know what the next line is. Okay. So the next thing we're going to do, just to show this, DistilBertConfig, DistilBertTokenizer, TFDistilBertForSequenceClassification. Okay, mouthful, but we only need to use it once. So TensorFlow as TF. Okay, and now really important thing when you're training, we're going to do a little bit of fine tuning today. So really important thing when you're fine tuning Hugging Faces is just that you want to make sure you're using your GPU. So I'll show you how to use this to make sure that we're using it in our training. So we're going to go list physical devices. Okay. So we see the name of our physical device right here. GPU. I have the subscription. If you have this is on your desktop, you would get a list of your physical devices, and this is the name that we're concerned about right here. Okay. So that's just to be aware of, and you'll see how we're going to use that later on. Okay. I have the data set coming from my GitHub reservoir. So if you can download the data set if you want, or you can go get it right from my GitHub reservoir right here. Okay, so nice and easy to use. Okay, so going to go here, doing the project, we have article link, which we're not going to use today, the headline, and then is sarcastic or not. So we're going to try and determine if the headline is sarcastic or not. Okay, so the first thing we're going to do is we're going to make sure that we convert the headline into a string, just so it's easier to work with going through with these libraries. So one of the interesting things, I did this out of habit almost, and I imported these libraries to work on NLP. One of the things is and maybe specifically for this data set, there wasn't really a lot of value. I think this is a good thing to try, getting rid of the stop words and using some of the string library to get rid of some punctuation. Specifically the punctuation, that usually actually helps transformers. I still tend to try if getting rid of the punctuation or getting rid of some of the punctuation helps or not. But with hugging faces with transformers, they actually need that context usually. So it usually is helpful to have the punctuation in here, and the tokenizer can deal with it in the correct way. So I have, if you want to know how to remove the stop words and the punctuation, I have the little, I left the code here because I did try it with and without, and it did work better without. So I did leave it though. And I also find stemming traditionally has usually helped. And here I'm doing from the NL key stem porter. I'm going to import the porter stem library. This is truthfully quite helpful in most NLP problems, but again, with transformers, it becomes a lot less important. And usually this, I would say this is something that I would not normally do. I still try it usually, but it doesn't normally help on NLP problems. It can, but it's not likely because transformers are really quite powerful. So I might get rid of some of the special characters though, some of these other things, but really this is, I didn't do this, right? So this is highlighting things that we could have done, but we didn't do. But there is a really, really important type of pre-processing that we need to do, and that's adding these close and sep tags. So this is the way the model will understand where the beginning of the sentence begins and where the sentence ends. So this is just a really important, this is how it was trained. So this is just something we need to add. So we're going to write a little lambda function. We're going to go apply this lambda function when we have x, which is basically apply, is going to iterate through each row. And when we get to each row, what it's going to do is it's going to give us the, it's going to take x, and what we're going to do is we're going to go add C capital CLS, and then space. And then what we're going to do over here is we're going to go quotations, square brackets, square brackets, and capital SEP. Okay, and this is just every transformers will have different tags and stuff. Well, not all of them have different tags, but they can have different tags, and this is really dependent on what they were trained on. Okay, so we're going to run this, and then we can see as we do that, we now have our tags, and this is specifically for the BERT model. Okay, so most of the BERTs will have this CLS and CEP sep to when they're separating the sentences. Okay, so what we're going to do here is we're now going to import the tokenizer. Now that we have this ready for the tokenizer, really very light on the pre-processing if you're noticing. Okay, you can do lots of the other pre-processing, but you'll find it can help, but it normally doesn't actually add too much value. Okay, so what we're going to do here is we're going to use the DistilBert tokenizer. And we're going to go then from underscore pre-trained. Okay, so this is the DistilBert base case. Oh, I'm just noticing here I spelled tokenizer wrong. DistilBertTokenizer from pre-trained, DistilBert uncased, and I'm going to do the number of labels is the sarcastic right here in value right here. Okay, so there's two kind of labels, and then what we're going to do is tokenizer. And what I want to do is I want to tokenize my data. I'm going to give it my data frame in a list format, not in a pandas series, in a list. Okay. What I'm going to do here is add padding and truncation right there. And then return tensors. We want to return TensorFlow tensors. And then I guess not the most important thing, but a very important part of working with transformers. We want to return attention mask. Oop. I know I did spell that. I return attention mask. Done. Tokenize the data. Okay, so padding, truncation, return tensors, and return attention mask equals true. Okay, so we want the attention mask. This makes it a little bit more difficult to think about because your input now is going to be two things. It's not just going to be the one row, it's going to be the attention layer, which is really zeros and ones to represent if it was padding or if it wasn't. This is one of the attention factors that allow transformers to really work well. So this is an important step. What I'm going to do is I'm actually going to put this into data frame so that it's easier to do this next step after we do the train test split. Okay, so data frame here. I'm going to put in the input IDs from the tokenized data. So there's basically two parts to the tokenized data, the input IDs and the attention mask. So we're going to make an individual variable for both of these. Okay, and then so the data frame for this. Okay, and so then what we're going to do as type, we're going to make sure that our variables are set to an integer. So as type int. And then I'm going to do, this one's probably fairly easy. If you were at Hugging Faces already, you probably know about train test underscore split, nothing new there. Okay, now what we're going to do here, this is a little bit not tricky, I guess, in this sense, but what we're going to do is we're going to do the train test split on our input IDs, this value right here. Because I put it into a data frame, I'm going to have access to the index values, and it'll be really easy to select out my attention mask train and my attention mask val. Okay, so what I'm going to do here is I'm going to select the iLock of the index trains, and I'm going to go index. So I'm just going to get the index of the train values, the index of the IDs, and then the index. So we're going to go iLock here and get the index of the val. So we're just going to select the vals from the attention mask, and then we're going to select the train from the attention mask. So there we go, and we have our shapes right there. So we have 21,000 rows and 5,000 rows in the validation set. Okay? So what we're going to be actually passing to our model is not just one data frame anymore. We're passing it a dictionary, and it's going to know that input IDs are the input IDs, and that attention mask in this specific format with the underscore here, everything exactly the same, is the attention mask. So this is the way it was set up, as a functional model that it key value pairs attaches the name here, the key of the dictionary, to the data going into the model. Okay, so what we're going to do is we're going to do, instead of none, we're going to do input IDs. Next one we're going to do is attention mask. Okay, this is our train input dictionary, and validation input dictionary is going to be IDs underscore val, and attention mask underscore val. So there we go. So now another really important step of the, what you call this, of building our model is this custom, or this config file, or well, not really file. These are how we kind of essentially set the hyperparameters for when we're loading in the model in this next step. So we're going to give it this custom config. Okay, so what we're going to do is, I'm just noticing here that I'm putting in the number of labels right into this. I didn't do this originally, but to get a better model, I did. So what we did here is, if you don't do the number of labels, if you decide not to use a custom config, you can set the number labels in the model right here when you're importing it. And if not, we can do it, or if you are going to use a custom, which I would recommend, we're going to use it right here. Okay. So we're going to do this first one is hidden size. Okay, so num labels, hidden size. Next one is num hidden layers. Okay. And the last one is hidden drop out. Hidden dropout. There we go. And we'll run this custom config. Oh, I forgot to actually call what I'm going to do. So I want to use here the DistilBertConfig. DistilBertConfig. And there we go. Okay. I'm going to train this model for 75 epochs. So the way that we're going to do this, initialize the model right here. So we're going to go TF, capital TF, DistilBert for sequence classification. Okay. Mouthful. And then from, we only have to do that one time, from underscore pre-trained. Okay. And then here, just notice here, we're in the config equals custom config. And this is where you could change your hidden sizes, your intermediate size. The one that was recommended by default is 3072. The best model that works well, that is the least complex, is generally going to be the one that's the most predictive. So I used only 56 in this middle one. So it really didn't need to be. This is a fairly simple data set in a binary classification problem. If it was text generation, you would need many more neurons in the middle and their intermediate layers. We didn't really need them here. Okay, so 56. Okay, so really quite small versus the default setting of 372. We need to define our loss, and we can do, because this is essentially one row, we're going to make sure that we do sparse. And it's sparse because generally sparse is a one hot encoded variable, but it's sparse because it's one column of data, so it's less. It's a sparse amount of data. If you can imagine you had 10 categories in one column, it's sparse in the sense that it uses less data. I feel that it's counterintuitive, but it's what it is. So it's the way I remember it, is sparse is one column, and categorical cross entropy is when we've one hot encoded our targets already. Okay, so cross entropy. Okay, and a really important thing here is that we're going to do from underscore logits equals true. This is how the model assumes things are going to work. We really need to do it from logits, which are the 0 to 1 probability output versus the solid classification. So from logits, really important. This is how the model works. If you don't, your model just really won't train very well. So it's a simple thing, but it's really important to remember that we do this. We're going to do Atom as our optimizer, just a good one in general, but good for NLP. And what we're going to do here is we're going to say optimizer equals optimizer, and loss equals our loss function right there. Okay. And I should say pre-trained. There we go. Oh, spelling. It's tricky sometimes. But it's good that I learned this, because I'm eventually going to, the more that I type this out, eventually, it'll take some time, but I'm eventually going to remember that this is an ED here. By forgetting it, oh yeah, I got to remember pre-trained, not pre-trained. Okay. And it makes sense. Pre-trained, good English right there. One of those things, just practice getting those errors is a good thing. That's how you're going to learn things. Using that auto fill, the AI code generation is good. But as you start to get to more and more advanced things, if you don't really understand well how those things that lower down work well, you're going to have a really tough time. Might generate the perfect amount of code. It doesn't always. And so it's one of those things that you need to really understand what's going on to be able to use it well. So just looking at the number of layers here. If we want to choose how many layers we're going to train in our pre-training here, what we would do is we would go, so just going model.layers gives us a list of the number of layers. We have 4 layers. So I'm going to say, let's not train the first 2. Okay, so what I'm going to do is model.layers, model.layers, and then I'm going to say the first 2 layers, so 0 and 1 up to 2, we're going to make those not trainable. And then what we're going to do is layer and model layers from 2 to the end, so 2, 3, if there's 4 layers, 0, 1, 2, 3. We're going to go layers equals, we're going to go here, layer trainable equals to true. Okay, so we're going to make the last 2 layers trainable and the first 2 not trainable. Okay. Nope, I gotta make sure I run this one up above here. Run the codes in order. Okay. So this is where we're going to use this GPU right here. So remember I said right at the very top, let's go back up to that. Right here, I had GPU, my devices right here. I got the name right here, GPU 0. Not a very interesting name, but right there I'm going to say with tf.device GPU 0 right here. So now when I fit my model, it's going to train. So model.fit. Here's my input dictionary that we made up above for the train, Y, the validation input dictionary, and the Y val. Okay, batch size 32 and number of epochs I did 75. So just because it's going to take a really long time to train, not super duper long with the epochs, but it's still going to take a good amount of time. It takes a long, even if you have your GPU turned on, you have to, it's not necessarily using it. So you need to make sure that you use this TF with device. So this is finish the project, and then we'll come back up and I'll just, we'll train this and start making sure it works. So here we're going to put the training history into data frame, to a data frame and history.history, and this is coming out of the training right here. So history equals to model.fit, and I'm going to go plot, and actually it's just by default is a line plot, so it works well for plotting our model history. That is like just a really good short way to plot our model history. Okay, and then here what we're going to do is we're going to do plot grid and get the grid behind this, and so we can really see it. Is our model improving? It's good to have those grids, I find, to make a little bit of detail. So our model is a big model, even with our smaller version of a big model. But what we're going to do is we're going to TF device when we're going to even predict with our model. So TF, we're going to use our device again. We go model.predict, and we get a very good score this time. Truly, we get a really good model here. We're going to import just the last step here, classification underscore report, and we're going to import our classification report to do here, and you can see here we got a 92% accuracy, which is quite good, I would say. Could be better. I'm sure we could find some pre-processing things to do to this as well. There's probably some funny characters and stuff like that. There's a lot more that we could do to this to help make it a little bit more better, but I wouldn't say that punctuation is the secret. It's be looking for those, a little bit more inspection on the data set and looking for things that don't really fit into the standard lexicon, into our standard, like random, unknown words could be a big thing. Maybe putting more common versions of misspelled words, correcting spelling and stuff like that. That our tokenizer would not be able to deal with. Misspelled words is just a misspelled word, so it's an unknown word. And by looking for those and finding those, we could find if we could improve this model. Okay, so there we go. So as we got to the end of the classification report, I wanted to show, don't need to say remove there. I was going to delete this, but I don't actually think I should. So this is kind of how I was doing the experiments. This is the different things that I tried. I started off right here. I did all of the layers are trainable. I tried for 200 epochs. I added the tags. This is my initial scores that I got. What I used, and this is actually just me copying and pasting the thing from up above. I do this, right? Because you do so many. I'm trying 75 epochs. I'm going to change a little bit and see what I get here. Change, and really just changing one thing at a time. And really seeing what's going to have an impact on my final output of my model, and just trying to working towards getting that better model. And I finally ended up on this architecture that worked really well. And I, playing with the dropout layers, the dropout percentages here, I found was quite valuable as well. Okay, and so let's just start running this and see, make sure it runs fine, so I can say goodbye and make sure you have a working project. Oh no, we got number of epochs is not defined, so let's do that. Where did we define number of epochs? Right here. So number of epochs, and then let's go ahead and see if this starts running. Okay, fit our model. So we have a running BERT, DistilBert for classification, for sequence classification. And sequence classification just really means it's a string of text. Okay, so thank you so much for joining me today, and I will see you for the next project.